All right, going on page 66 when we are done. So when we graph, first thing that we need to do is factor to find our zeros. This is already factored for us, right? So that's good that it's already factored. Do I have any holes here? No. Okay, so there's none of those. My roots are at -2, 0. And by the way, you have a quiz tomorrow on the graphing, so I would spend a whole lot less time worrying about this and pay attention to what's going on up here. All right, my vertical asymptotes, x equals -6 and x equals 3. Do I have any tangency or togetherness? Yes. Which one? Both, right? Tangency comes from the numerator. Togetherness comes from the denominator. So if you always see tangency and togetherness together, you can think about, numerator and denominator. So that means that I have tangency at x equals 0, and I have togetherness at x equals what? 3. It's coming from the denominator. Okay, we good with that? Do I have a horizontal asymptote? What's the degree of the numerator? It's tied because the degree of the numerator is a cubic, denominator is a cubic, so my horizontal asymptote is y equals 1. There are no slant asymptotes then because you can't have both. Y-intercept, what's that going to be? 0, 0. Because once you substitute in the 0, that's super simple here. All right, so I'm going to rewrite this so I can read it down here. X squared times x plus 2 over x minus 3 squared times x plus 6. Okay. So on my number line here, I've got to put this -6, then I have a -2, 0, and 3. So when I substitute these signs in and this gets squared, what happens? It's always positive, right? There's no way to get a negative out of there. And what happens here? Always positive, no way to get a negative, right? So can I just ignore those? Because the positive doesn't change my signs, right? I can just ignore these two. These are the two that are really driving what's happening with the signs. So if I substitute in like a -7, it's going to give me negative over negative, which is positive. If I look at -3, it's going to give me negative over positive, which is negative. If I think about a -1, it's going to be positive over positive, which is positive. Between 0 and 3, I'll use 1, so that's positive and positive, which is positive. 4 would give me positive over positive, which is positive. So my graph looks something like this. So let's think about what's happening at each one of these spots, right? I have a vertical asymptote at, bless you, at -6. So my graph looks like this at -6. At -2, I have a 0, so it's going to cross the x-axis. At 0, it's also a 0, but it's positive to positive. So what's happening here at 0? Bounce. This is my tangency, so it's going to bounce, something like that. Then at 3, I have a vertical asymptote, and it's positive, positive, because I have togetherness that we wrote down, right? So it's going to look like that. That makes sense? That's what those tangency and togetherness means when they're matched up like that. All right, so let's go on over here and plot everything we can. Let's see what we've got. We've got roots at -2 and at 0. We've got a vertical asymptote at -6. And at 3. And then I've got tangency and togetherness, which we'll come back to. Y equals 1. And then a y-intercept at 0, 0, which I already have. Okay. So those are my 3 asymptotes, and then the 2 points that I can plot. So here's what I know from this. From -∞ to -6, my graph is positive. So it's somewhere up here but I don't have any points at all, so let's go find some points. Do x, y. This is -6, so we'll try -7. So when I substitute -7 in up here, I'm going to get -7 squared times -5 over -10 squared times -1. So overall, in the end, this is going to be positive. We agree with that? So this is going to give me 49 times 5 over 100. 5 goes into 100 20 times, so I just get 49 over 20. I have to actually multiply that stuff. So that means that's 2 and 9/20, which is about 2.5. So I can go to -7 and 2.5. And that 1 point, like that 1 point for that section of the graph is probably enough. So because of where it is, I think we're good with that. So I can draw this piece of the graph in like so. And remember, make sure that your points actually look like points. They can't be microscopic dots where I can't tell if you have a point or not. They don't have to be ginormous, but just they need to look like you actually put a point there. All right, so then between -6 and -2, my graph is negative. So, and I know that on either side of the asymptote, it has to be opposite. So it's going to come up to here. Between -2 and 0, it's positive, right? And then from 0 to 3, it's positive. And here's where my bounce is. So it's going to bounce. And then when it hits this asymptote, well, it doesn't actually hit the asymptote, but it's going to come up this way. So I feel like those 2 points probably enough, because I know it has to come up like this. It has to bounce here and then continue like that on my asymptote. So there's the middle part of my graph. Because when you're in between those 2 vertical asymptotes, it's either going to look like a cubic or it's going to look like a quadratic. And then from 3 to infinity, it's positive, and there's togetherness here. So I know it's coming this way, and it'll look something like that, but things are not always symmetric, so I need to get a point over here. So we will try, let's see, is that at 3? So we'll try 4. So I get 4 squared times 6 over 1 squared times 10, right? So you can cancel that out, make that 5 and that 3. So it's going to give me 16 times 3, which is 48. So that's 48 over 5. How many times does 5 go into 48? 9 times. So it'd be like 9 3/5. So I can go to 4 and go to 9 3/5. And that doesn't really help me much at all. So I could try 5, but maybe we'll try 6, get a little farther away. For 6, it's going to give me 6 squared times 8 over 3 squared times 12, right? And so this gives me 36 times 8 over 3 squared times 12. So watch this. 12 goes into 36 3 times. This 3 can cancel out with one of those, and I have 8/3, and I didn't multiply anything. Okay? Except I did 6 squared, and that was it. Learn how to manipulate things when you're not multiplying big numbers. You are completely wasting your time that you don't have if you were always multiplying everything out. 3, 6, and then 8/3 is like 2 2/3. So I got that point there. So I feel like those 2 points are probably good. Something like that. Okay. Questions about that one? We good? All right, good deal. Next one. So this next one is all factored for me. Sometimes that's a blessing, sometimes not so much. Do I have any holes here? No. So there's none. Roots, -2 and 3. Vertical asymptotes, x equals -1 and x equals 2. Do I have any tangent C or togetherness? Yes, which one? Tangent C. So I have tangent C at x equals -2. Do I have a horizontal asymptote? No. It's a cubic over a quadratic, so that would be a no, which means there's a slant. And what do I do to figure out slant asymptotes? Divide. Okay, so in order to divide, what am I going to have to do? multiply. You have to multiply before you can divide. So I have to multiply this out. So in the numerator, this x minus 3, you should be able to do a perfect square trinomial very quickly. X squared plus 4x plus 4. And in the denominator, you should be able to multiply that very quickly. X squared minus x minus 2. So like I've said before, if you're still trying to do the box, you don't have time for that mess because this is a very small part of this big problem. And then you need to multiply out the numerator. So I'll give you a minute to do that. Again, that should be something you should be able to do with ease. And that's what you should come up with, right? So then once I get this, can I do synthetic division? No, you got to do long division, and you may not have a whole lot of space left right here because it seems like I have more than you do, but you have more space up here than I do. So if you need to do your long division up there, you can, or wherever you have room. But x squared minus x minus 2 divides into x cubed plus x squared minus 8x minus 12. So x squared goes into x cubed x times. So give me x cubed minus x squared minus 2x. Go through and change my signs. So I get 2x squared minus 6x minus 12. X squared goes into here a positive 2 times. 2x squared minus 2x minus 4. And then really the rest of this doesn't even matter because that's my remainder. So I get y equals x plus 2. Long division, got to be able to do that quickly and accurately as well. And again, you don't have time to go off to the side and write all those extra little steps that you may have done at one point. That's why we reviewed and reviewed and reviewed over things, because you got to be able to apply them quickly and accurately. And then my y-intercept. Which form is easier to look at for the y-intercept? Oh, well, that's a matter of opinion. If you like I like this form better, but it's fine. Whatever works for you. But I would say the other one over there. So my y-intercept then is 0 what? Positive 6. Okay. And then let's look at our number line here. So on my number line, let me rewrite my thing. I can't see it. Here I want the factored form. This is x minus 3 times x plus 2 squared over. All right. So on here I have a negative 2, negative 1, 2, and 3. All right, so this one again, this is going to be positive no matter what, so I can just ignore it. So start with negative 3. That'll give me negative, negative, negative. That's negative. Negative 1.5, negative, negative, negative. That's negative overall. 0, negative, negative, positive. 2.5, the negative, positive, positive. And then a 4 would give me positive, positive, positive. Okay, so that's what my graph looks like for the most part, or where the positive and negative is anyway. Then I'm going to go and graph what I can. I've got roots at negative 2 and at 3. And a vertical asymptote at negative 1. And one at 2. And I have tangency at negative 2, which we'll get back to. Slant asymptote at y equals x plus 2. So I can go to 2 on my y-axis. When the slope is 1, that's good because we can just go diagonally through the squares. And then y-intercept of 0, 6. All right, so that's everything I've got so far. And let's look at what's happening here. Between negative infinity and negative 2, my graph is negative. Okay? And then that's where my point of tangency is, so it's going to stay negative, and here's my asymptote, so it's going to come up something like that. From negative 1 to 2, it's positive, so that means it's all up here, which means this part's going to look like a quadratic, right? From 2 to 3, it's positive. I'm sorry, from 2 to 3, it's negative. So if it's up here, this is opposite. It comes down here, and then it's going to be positive. So I feel like this part of the graph, I could probably go ahead and do that one. It looks something like that, but we'll hold off for just a second. Because what's weird about what we have right now? The slant goes through a point. Your slant asymptote goes through that point. Now, we know that we can cross those asymptotes. We haven't had one where it actually has a point on there. And we figure out what's happening, because I know that this part's going to be up against this asymptote. It's going to bounce here, but I don't know if it bounces on this side of the asymptote or if it bounces on this side of the asymptote, and if it crosses back or not. So I got to know what's happening there. I know it crosses at least once. I got to figure out if it crosses more. When we did that yesterday on this one, to figure that out, or was it this one? Oh, no, it wasn't it. Oh, shoot. Did we do that on one? Is it this one? Oh, what number was it? Do we know? I thought I knew, and I was going to show you, and then clearly I don't. Ah, it was this one. So what we did was we knew it crossed once, right? And then we wanted to see if it was going to cross again. So we took the function and we set it equal to the asymptote, right? Because the function value is 1 there. So this is our actual function, or it's the expression part of the function, and set it equal to the expression part of the asymptote. Yes, it was just a value here because it was a horizontal asymptote. If it's a slant asymptote, this isn't going to be a number. It's going to be an expression. Okay? Does that make sense to you? Because the asymptote here is y equals 1. That's where that came from. So on this one that we're on, is it this one? Yeah. This one that we're on, the asymptote is x plus 2. So it's a system of equations. It's when do these two functions intersect? And all that is a system of equations. So y equals x plus 2 and y equals this mess over here. And so you just substitute in for y, and we'll set the expressions equal to each other. So that's what we're going to do down here. So we're going to use the multiplied out version. That way we don't have to multiply it out again. And that means we have x cubed plus x squared minus 8x plus 12 over x squared. Oh, thank you. I can't read my handwriting. Okay. Minus 12 over x squared minus x minus 2. And I set that equal to the expression for the asymptote, which is x plus 2. Right? And then I have to see when they'll intersect. So I have to solve this, basically. So I'm going to multiply both sides by this denominator. So I'll get x cubed plus x squared minus 8x minus 12 equals x plus 2 times x squared minus x minus 2. So you should be capable of multiplying this out quickly and accurately. I'm just going to give you what it is so we're not spending too much time on that part. But we've got x cubed plus x squared minus 8x minus 12 will equal x cubed plus x squared minus 4x minus 4. So that's what you get once you actually multiply that out and combine like terms and everything. So now when we start to solve this, if I subtract x cubed from both sides, those just cancel out, right? Subtract x squared from both sides, those cancel out. So now I'm going to keep my x's positive. So I'm going to add 8x to both sides. So that'll give me negative 12 equals 4x minus 4. Then add 4 to both sides. So that'll give me negative 8 equals, not negative 8x. Negative 8 equals 4x. So x equals what? Negative 2. So how many times do these two things intersect? Once. I only have one x value, just once. Okay? I could have an infinite number of them. I could have 2. I could have 3. But I have 1. And I already know what that one is, right? When x equals negative 2, that's when they intersect right there. Okay? So that's it. It means it's not going to intersect again, and that's important. If you don't know that, you don't know what to do with your graph over there. So when we do graph this, this part is over here. This bounces. It has to bounce on the other side, because otherwise it's going to, and then it comes back down like so. Okay. We good? All right, I want to need an arrow over here. Now, in the middle part there, it should look like a quadratic because I know it stays all positive. This isn't necessarily the minimum. It could come all the way down here. Could it come all the way down here and cross this asymptote? No, because it only crosses once, right? And then, so let's try another point, though. Let's see what happens with 1. I can't see my function anymore. So if I substitute in 1 there, that'll give me -2 times 3 squared over -1 times 2. So these two things cancel out, so that just gives me 9. So at 1, I'm at 9, which means this looks something like that. Right. Not necessarily the exact parabola shape that you would expect. And then over here, I didn't draw this a minute ago because I didn't know if it was going to cross the asymptote again, but I know it's not going to because it only crosses once, and it's not going to cross the vertical one, so it just looks something like that. Any questions at all? Good? All right, isn't graphing fun? It's fun. Oh, the answer is yes. All right. So this one's partly factored. So I got to factor it the rest of the way to see if I have any holes and see what my roots are. So this will be x minus 4 times x plus 3 times x minus 1 over x plus 2 times x minus 2. So is there any point discontinuity? No. That's a none. My roots are -3, 1, and 4. Vertical asymptotes, x equals -2, x equals 2. Do I have any tangency or togetherness? No. Do I have a horizontal asymptote? What's the degree of the numerator? 3, and the degree of the denominator is 2, so there is none. That means I have a slant asymptote. It means the fact that it wasn't factored all the way was actually kind of nice because I have to multiply together. So I'm going to need to multiply these two together. Make that happen. The denominator will be x squared minus 4, and then get the numerator. It's going to give me x cubed minus 2x squared minus 11x plus 12. Right. I figure those of you that are actually multiplying it out are capable of doing it, and the people that are waiting for me to do it are always going to wait for me to do it, so it's pointless for me to waste your time. So I need to divide here. Can I use synthetic division? No, so I have to do long division. So x squared minus 4 divides into x cubed minus 2x squared minus 11x plus 12. And again, you may have to do it up there where you have a little bit more room. So this goes into there x times, so this gives me x cubed minus 4x. Change my signs. That brings down to -2x squared minus 7x plus 12. X squared goes into -2x squared minus 2 times. The rest doesn't even matter because I don't care about my remainder. Y equals x minus 2. Okay. All right, so then what's my y-intercept? 0, what? -3. Good. All right, so then to look at my number line, let me rewrite this. F of x is equal to x plus 3 times x minus 4 times x minus 1 over x plus 2 times x minus 2. All right, so I've got 5 things I've got to put on here. I've got to put on -3, -2, 1, 2, and 4. And there's nothing I can ignore here, right, because I don't have any squareds anywhere. So negative 4 is going to give me negative, 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 which is negative overall. Now, sometimes when we do this, the signs alternate, and sometimes they don't, right? So are these signs going to alternate? When do they not alternate? When there's tangency or togetherness, right? Because that's where it's going to stay. If this was negative, negative, which it's not, but if it was, then here I'd have to have an asymptote and have togetherness, or I would have to have tangency. And I don't have either one of those things. So if you have no tangency or togetherness, they are going to alternate. Okay, so if you understand when it does and when it doesn't, I don't necessarily have to check every single sign. You still need the sign chart. It's still important for us to be able to get the rest of our graph, but this is going to alternate because there is no tangency or togetherness. It looks like that. I don't have to check the rest of them. Okay. All right, so on my graph then, I'm going to graph my roots, which are at negative 3, 1, and 4. My vertical asymptote at negative 2 and at 2. And no tangency or togetherness, no horizontal asymptote, slant asymptote, y equals x minus 2. Bless you. That. And then 0, negative 3. That's my y-intercept. Okay. Everybody okay with all that? Yes. All right. So once I look at what's going on over here, from negative infinity to negative 3, my graph is negative. Okay, it's coming across this asymptote here, it's negative. And then from negative 3 to negative 2, it's positive. I think it's going to look like that. I think I can go ahead and that 1 point is probably enough for me to figure out what's going on there. Right. And then from negative 2 to 1, my graph is negative. So it's negative down here, right? And then from 1 to 2, it's positive. Well, in between two vertical asymptotes, it's either going to look like a quadratic or look like a cubic. Which one's this going to look like? A cubic. Can't be a quadratic unless it's going to stay on, you know, well, I mean, I guess it could be a quadratic, but you have to, and actually, no, it can't be, because this is going to go to infinity and so is this. And so if you have points that look like this, that's not going to happen. It's got to be opposites. So it's going to have to look like a cubic, which means there has to be a point of inflection in here somewhere. When I come down and I come through this point, I've got to change my, whew, that's a little yucky there. Let me try that one more time. A little too squiggly. Come down here, and I've got to change my direction at some point, because otherwise, and it can't be a line, it can't go straight through those 2 points, because then it's going to, then it would come out to the infinities, which doesn't work. So you've got to have a point of inflection in there to make it look cubic-like. And then from 2 to 4, it's negative, so it's down here. From 4 to infinity, it's positive, so that 1 point there is probably enough. Give me what I need. Okay. Everybody okay with that? Any questions? All right, one more. Is this one fully factored? No, it's almost, but not quite. So what else can I factor out? Well, I can factor out a 3. Yeah, I know what you meant. X plus 4 over x plus 2 squared. All right, so any point discontinuity? No. And then my roots are at negative 4 and 1. Vertical asymptote, x equals negative 2. Any tangency or togetherness? Yes, which one? Togetherness. And that togetherness is at x equals negative 2. Do I have a horizontal asymptote? Yes, thankfully. I have a horizontal asymptote because they're tied in degree. What would that be? Y equals 3. Good. y equals 3, which means there's no slant asymptote. My y-intercept, so this one's not so easy just to look at, but it's not like it's crazy hard. This will be 3 times negative 1 times 4 over 2 squared. Those cancel out, so it's just 0, what? Negative 3. We good? I'm going to come down here and look at my number line to look at my sign chart. So this is f of x equals 3 times x minus 1, x plus 4 over x plus 2 squared. All right, so we've got negative 4, negative 2, and 1. So if I substitute in a negative 5, it's going to give me negative, negative. Denominator is always positive, so this is positive here. All right, so are these going to alternate? No, not straight across, bless you. Because here I've got togetherness here at negative 2, right? So this is my asymptote where my togetherness is. There's no tangency or togetherness here, so what is this going to have to be? Positive or negative? Negative. If there's no tangency or togetherness at this point, it has to change. This is where my togetherness is, so it's going to have to look like this, which means this is negative, this is positive. If you're not sure what to do with that, then I suggest you actually check your signs so that you're not making stuff up, because these need to match. It'll look something like this. So when I go to graph everything that I have, let's see. Got roots at negative 4 and 1. Vertical asymptote at negative 2. Got some togetherness at negative 2, okay? And y equals 3. Horizontal asymptote. And 0, negative 3 is my y-intercept. So this is my togetherness, which means the graph's going to come and look something like that. So you should have a general idea of what your graph is going to look like. Is it going to be symmetric? Like, is this asymptote a line of symmetry? What do you think? No, because if it was, then these points would be the same distance away, right? So it's not a perfectly symmetric type of thing. Do we know whether or not when it comes up, if it's going to cross this asymptote? We don't know. If the asymptote was y equals 0, then we would know because it would have to change from positive to negative. So we're not sure. So we need to go and check. All right. So we're going to set this. What is it? 3 times x minus 1 times x plus 4 over x plus 2 squared, okay, the expression from my function. I need to set it equal to the asymptote, which is what? Y equals 3, but what do I put over here? 3, just 3. So then to solve this, I'm going to multiply both sides by x plus 2 squared, so that's 3 times x minus 1 times x plus 4 equals 3 times x plus 2 squared. So what happens with the 30s? They cancel out, so I don't even have to worry about them. That's why you just jump in and start multiplying everything you can. I do need to multiply these now, so this is going to give me x squared plus 3x minus 4 equals, that's a perfect square trinomial, so x squared plus 4x plus 4. Then I can subtract x squared from both sides. I'll subtract 3x from both sides, so I get x over here. Subtract 4 from both sides, and I get negative 8. So x equals negative 8. What does that tell me? Does it cross the asymptote? Yeah. Okay, those two things intersect, right? Because I got a value. If they didn't intersect, what would an example of what my answer would look like? What happens? Like, if they're not going to intersect, what do you think I would get? I would have like no x's. So you'd have some statement like negative 8 equals negative 2 or something that's not a true statement, right? That's where your undefined comes from. So if you get something that doesn't make any sense and doesn't work, then they don't cross, right? But when you get something, that means when x equals negative 8, what does y equal? 3. That's the whole point of what we just did. So it does cross the asymptote. Over here, it's not going to because it only crosses at that one time. So I know over here, It's going to look something like that, but that doesn't really cross. It just gets really, really close. And then over here, I have togetherness, so I know it starts down here. Now, when I draw this and it comes up, is this going to keep on increasing? No, because when it comes up here and it goes through that point, I totally missed. This pen is ridiculous. Let me try one more time. A different angle here. When it comes up here and it comes through this point, oh, I missed again. I'm just going to make it bigger. I can't always do things at a certain angle here. It has to come back down. It doesn't keep increasing. It's concave down because it has to come and get closer and closer to that asymptote there. Okay, and that's what that one would look like. Because remember, that's talking about in behavior. And somebody asked me yesterday, and I don't think it was in this class, but when we were doing in behavior, they said, do we have to write out the in behavior even though you haven't been? I really wasn't sure what they were talking about. I said, well, we have been, because that's what this is. And they said, no, like as x approaches infinity, f of x approaches. And I said, oh, we're not writing it out in that form, but that's what this means. As x approaches infinity, f of x approaches 3. And as x approaches negative infinity, f of x approaches 3. Does that make sense? Like that's what's happening. It's getting closer and closer to 3. This one from underneath, but this one from on top. Okay? We good? Any questions? All righty, go ahead and tape that in like you did yesterday.